Okay, algebras, so don't be afraid of the word problems. When you look at a lot of math, that's our application, and that's what matters. So what we're going to do here is we're going to do this key in two parts. First, we're going to just go through and write the equations, and then you can go back and solve them and then check your work. You may solve using any of the three methods we have learned so far. We've reviewed graphing, we've reviewed substitution, and we've reviewed linear combinations. So our first step in all of these word problems is to read the problem. And remember, what I want you to think about is we are looking for two equations. In our systems unit, we'll find two relationships that we want to make sure we can show using equations. So even in a number, even in a sentence this small, there's two different relationships. So find the value of two numbers if their sum is 12 and their difference is 4. Okay, so my first step in all equation solving is going to be to define. The first thing I'm going to do is talk about my variables. We're going to let x equal my first number, and we'll let y equal my second number. My next part of my problem solving steps is going to be to write two equations. Two things about the relationships that I know are true. First of all, I know the two numbers have a sum of 12. Secondly, I know that the numbers have a difference of 4. And once I go ahead and I say that it's x minus y, I'm going ahead and automatically knowing that this is going to be my larger number. The next part is where I'm going to go ahead and solve my equations and solve for both variables. Once I solve them, I want to make sure that I state my final answer. And that always starts with the therefore the numbers are. And then I can continue going. So we're going to let you solve this system and then come back and let's look at number 2. Alright, your algebra test has 31 questions and it's worth 100 points. The test consists of multiple choice questions worth 2 points each and open-ended questions worth 4 points each. How many of each type of questions are there? Okay, so we've got 31 questions total and we've got 100 points total. We've got questions worth 2 points. We've got questions worth 4 points. How many of each types of questions are there? Now, this is an interesting kind of problem because we're always going to, when we look for our two equations, one equation is going to be about value and one equation is going to be about amount. And that's kind of our number of things we have, and this is kind of what the things are worth. And keeping these two conversations in mind helps us when it's time to write our equations. Alright, first of all, let's go ahead and define our variables. We have two kinds, 2 points and 4 point questions. So let's go ahead and let x represent our 2 point questions, how many of them we have. And let's let y represent our 4 point questions. Now, when we go to write our equations, we want to think about our two considerations. One has a value and one talks about amount. So when we talk about our amount, that's the easier one to usually do first. So our amount means that I've got, look, 31 questions. So I know that the number of 2 pointers plus the number of 4-pointers is going to be equal to 31 questions. Now when I'm going to look at the value part of the story, I gotta go look at what is everything worth? What is everything worth? So I get 2 points for every 2-point question, and I get 4 points for every 4-point question. Okay, so what is the test worth? There we go. It is worth 100 points. So once I have these two equations written, now I have a system where I can go and use this space to go ahead and solve my equations, and then don't forget to state your final answer. You would say, therefore, there are however many 2-pointers and however many 4-pointers. All right, so let's look at number 3. The drama club sells hot chocolate and coffee at soccer games. At the last game, they had sales of $200. This sounds like a value. They need to keep track of how many of each type of drink was sold so they can make a prediction for future sales. Monica knows that they used 275 cups that night. This looks like it's going to be our amount. How many cups? If the hot chocolate was 75 cents and coffee is 50 cents, guess what? These are our rates. How much of each type of drink were sold? All right, our first step, of course, is define our variables. Let's let X represent the number of hot chocolates sold. And let's let Y represent the number of coffees sold. Okay, so for the second step, when we go ahead and write our equations, I have two considerations, remember? I want to think about how many did we sell, and I want to think about what were they worth. So when I look at my amount, I know that I had this many cups. So this many hot chocolates plus this many coffees means I used that many cups. All right, let's talk about value. I know that 75 cents was for every hot chocolate, and I know that 50 cents was for every coffee, and I made $200. Now we have a problem here because this is in dollars and these are in cents. So we either add decimal points here, or we need to talk about $200 in terms of pennies by understanding that this is actually 20,000 pennies. It's easier to do this one so we don't have the decimals. All right, your next step is going to be to solve this equation, and then of course you're going to have to state your final answer. So go ahead and solve this, and then we'll check back in and take a look at our next one. Okay, so now we've got a coin problem, and again, we really have to consider the difference between an equation that talks about the amount as far as what is the number of things we have versus the value, how much something is worth. Typically, this is where our two equations come from in practical application. All right, so Bob's got some coins. Let's take a look at what he has. 60 coins. That 60 coins sounds like it's going to be a number to me. He's got quarters and he's got dimes. The coins' combined value is going to be $9.45. There it is. It says it right there. How many of each quarters and dimes does Bob have? So when I go to define my variables, I'm going to go ahead and let Q represent my number of quarters. And I'm going to go ahead and let D represent my number of dimes. So what we're going to do for this one is we go back and we look at, he's got 60 coins. So that means that when I go to write my equations, I know that the number of quarters plus the number of dimes is equal to 60. There's my first equation about my amount, how many of them I have. Now here's a tricky one. I'm going to start talking about my value. The coins have a value of $9.45. So my dimes, my number of dimes, we all know that each dime is worth 10 cents. And we all know that each quarter is worth 25 cents. So think about this. 25 cents for every quarter plus 10 cents for every dime is going to equal the amount of money I have. But guess what? See how again I'm in cents? I'm just going to write how many cents. So a lot of times we think about multiplying this by 100 because 25 plus 10 represents my number of pennies. So $9.45 represents 945 cents. All right, your next step is going to be to solve this one, and then you're going to have to state your final answer. Let's take a look at number 5. At Giant, 3 apples and 4 bananas cost $4.85. 3 apples and 10 bananas costs $8.75. Find the cost of an apple. Now when we go for this one to define our variables, instead of looking at the number of each of the things we're solving for, if you read carefully, we already know that number. So I don't need to know my number because I already have it. I have 3 apples and 4 bananas for that cost, and 3 apples and 10 bananas for this cost. So I'm not looking for my number of things. Instead, when I define, I'm going to let X equal the cost of the apples. I'm going to go ahead and let Y equal the cost of the bananas. So when I go to write my equation, it's not the kind of problem that has this amount and value conversation like up here. Instead, I have to look at and compare each of these costs. So this one's a little bit different from previous ones. I know that 3 apples plus 4 bananas cost me $8.85. I know that 3 apples plus 10 bananas cost me $8.75. So this is my system now where I have these 2 rates. This is like equations in standard form where I have 2 rates. I have the cost of apples, I have the cost of bananas when I put them together in a system. Now this one's set up kind of nicely, don't you think? Because I can go ahead and try to find a 0 pair. I'm going to go ahead and probably multiply this one by -1 and cancel that out. All right, you go ahead and you solve this system. And don't forget, what I need you to do is solve. And then don't forget, you need to state your final answer. Okay? All right, let's take a look at number 6. Michael buys 2 bags of chips and 3 boxes of pretzels for $5.13. He buys another bag of chips and 2 more boxes of pretzels for $3.09, and I'm looking for the cost. So when I'm looking for the costs, that's going to be the same problem as like number 5. So when I define my variables, I want to make sure I'm talking about X represents the cost of his chips. And then we'll let y represent the cost of his pretzels. So when we go ahead and we write our equations, we have 2 bags of chips and 3 pretzels, and that cost him $5.13. I have 2 boxes, but another bag of chips, so just 1 bag of chips plus 2 boxes of his pretzels cost him $3.09. So again, this is going to be a system of equations that I can solve using either substitution or elimination. It's up to you. So I'm going to go ahead and ask you then to solve. And then I want you to state your final answer. All right. The length of a rectangle is 3 more than twice its width. The perimeter of a rectangle is 36 feet. Set up 2 equations to find the length and width. All right, so our first step, of course, is to define our variables. Now, with perimeter problems, what's interesting is we kind of have 3 variables. I know that perimeter is twice the length plus twice the width. So let's make sure we understand that formula. If I have the perimeter, that's going to represent always my distance around. And I want you to pretend like you're walking on the line around the box. And what we know, it's a rectangle, so we know that the length of my sides opposite are going to be the same. So when you look at this picture, I've got my purple sides that have the same length and my red sides that have the same length. Now, it doesn't matter what you call length or width. Typically, people like to call the length the longer one and the width the shorter one. But I know I've got 2 purples and 2 reds that I want to add up the distance around, and that's going to be my length and width. So the perimeter problems are a little bit different when we set them up, because we're going to go ahead and write this equation, and we're going to substitute right into it what we know about the length and the width. So we know the length of a rectangle is 3 more than twice the width. So the length is equal to 3 more than twice the width. That's a substitution property right in the making. My perimeter is 36 feet. So right away, I'm going to take this 36 feet that was the distance I walked around and put that in for my perimeter. So when I have twice the length plus twice the width, I already have this equation over here. So I go ahead and say 3 plus 2w is equal to my length. So my 36 was the value of my perimeter. And I have twice my length plus twice my width. And they told me the length of a rectangle is 3 more than twice its width, which is how I got that. So when I go ahead and I write my equations and then solve my equations, I'm really set up for success on this one. And then, of course, don't forget to state your final answer. Therefore, the length and width are. All right, so go back and solve each of these and come back and look at the key to see how you did.